Hi students, welcome to this short video lecture on community dynamics. This is part of our overall discussion of evolution and speciation and is the last lesson in this unit. After reviewing this session and completing the assignments that go along with it, you should be able to explain what ecological succession is and be able to give some examples of the various stages of succession. You should also be able to understand the concept of ecological disturbance and how it affects communities. We used to think that stability was the optimal state of an ecosystem. For instance, in the American West, we routinely extinguished forest fires, thinking that we were preserving the natural forest. Now, we realize that forest fires are a natural part of life in a forest ecosystem, and we understand that communities are in fact dynamic and ever-changing. Some of our original ideas about the development of communities were proposed by Henry Chandler Cowles, who proposed that communities develop in a sequence of stages. H.A. Gleason modified this process and viewed it as more unpredictable and based on the ability of individual species to colonize and grow in a given community. Nowadays, Gleason's view is more widely held. Succession is a process in which organisms occupy a site and change its environmental conditions, gradually making way for another type of community. In primary succession, bare land is colonized by living organisms where none lived before. Secondary succession occurs after a disturbance, when a new community develops from the biological legacy of the previous one. In both kinds of succession, organisms change the environment by modifying soil, light levels, food and water supplies, and microclimate. This change permits new species to colonize and eventually replace the previous species, a process known as ecological development or facilitation. In this figure, we see a conceptual drawing of primary ecological succession in a boreal forest. Primary succession in boreal forests involves 5 main stages. Initially, exposed rocks are colonized by lichens and mosses, which trap moisture and build soil for grasses, shrubs, and eventually trees. Periodic fires can set back the trees, initiating secondary succession. Aspens spring forth from roots, pines germinate in openings, and a new forest begins. In this drawing, the whole spruce, Ballast firs and para birch trees represents the climax community of the mature forest, which will eventually undergo some disturbance, like a fire or a flood or an insect infestation, and will return to a lower stage for the process to repeat itself. Ecologists have found that disturbance benefits many species, much as predation does, because it sets back the most competitors and allows less competitive species to persist. In northern deciduous forests, maples, especially sugar maple and the more recently derived Norway maple, are more prolific cedars and more shade tolerant than most other tree species. After a decade without disturbance, maples outcompete other trees for a place in the forest canopy. The dense shade of maples basically starves other species of light. Most species of oak, hickory, and other light-requiring trees diminish in abundance, as do forest understory plants. When windstorms, tornadoes, wildfires, or ice storms hit a maple-dominated forest, trees are toppled, branches broken, and light once again reaches the forest floor. This stimulates seedlings of oaks and hickories, as well as understory plants. Breaking the grip of the strongest competitor is the helpful role disturbances often play. Consider the Kingston Plains in Michigan's Upper Peninsula, for example. Clear-cut logging at the end of the 19th century removed the white pine forests that once grew here. Repeated burning by pioneers who hoped to establish farms removed nutrients from the sandy soil and changed ecological conditions so that more than a century later, the forest still hasn't regenerated. Given extensive changes by either humans or nature, it may take centuries for a site like this to return to its pre-disturbance state, and if climate or other conditions change in the meantime, it may never recover. The Yellowstone National Park fires in 1988 burned 1.4 million acres. Recovery of the region, which was 80% lodgepole pine before the fire, has produced greater diversity of vegetation, including savannas and more mixed forest types. In general, we can classify disturbances as being either a biotic or abiotic. The causes of biotic disturbances involve things like disease, predation, overpopulation, depletion of resources, etc. Abiotic disturbances include things such as hurricanes, fires, and earthquakes. Biotic disturbances are density dependent in that they depend on having a certain density, that's to say number or arrangement of species, in order for the disturbance to proceed. For example, a population of humans living close together in a village exposed to the smallpox virus will likely pass the disease to many members of the community. If the person who originally contracted smallpox lived alone in a cave, the disease would not have spread. Likewise, a population of rabbits living on a prairie will all die if a flood or a fire comes by and buries their rabbit burrows. It does not depend on how many rabbits live there, it's density independent. So we can generalize by saying that biotic disturbances are density dependent and abiotic disturbances are density independent. In this section, we have learned about the concept of ecological succession, how organisms occupy a site and change its environmental conditions, gradually making way for another type of community. We also learned that communities are dynamic and often change over time, adapting to new environmental conditions. We learned about disturbance, and that disturbance is any force that disrupts the established pattern of species diversity and abundance, community structure, or community property. Disturbances can be biotic or abiotic, and that it can take decades or centuries for ecosystems to recover from severe disturbances, if they can recover at all.